You have to find this final equation that comes out after solving these two half equations and see which of the statements match this. So let's solve this. So there's 3 electrons here and 2 electrons here. I'm going to multiply this by 2 and 3 respectively to get the number of electrons to be constant throughout. So I did this over here, and now since this is multiplied by 2, this entire equation is multiplied by 2, I get 6 electrons here, and every single coefficient is multiplied by 2 over here, so it becomes 2MnO4, 4H2O, and then 6 electrons. Similarly, every single coefficient is multiplied by 3 over here. Now what I will do is I'm going to add both sides of the equation. Now I'm going to add both sides of the equation. So this is the left hand side. So the left hand side gets added to the left hand side over here, and the right hand side gets added to the right hand side over here. I can see some terms just end up cancelling out. This gets cancelled out and then this gets cancelled out. So that's how it works. Now I will also see that there's 4H2 over here and then there's 3H2 over here. So these can kind of cancel out. So like this becomes, so this would be 4 minus 3. So I would be left with 1H2O over here. And similarly, it's 8OH over here on this side, on the right hand side of the equation, and 6OH over here. So these two end up cancelling out and this becomes 2OH. And now everything else remains the same. U over here, if I match my equation, is going to be 2. Z over here, this is also going to be 2. Z is the one attached to OH, this is going to be 2. And X over here is going to be 2 as well. So 1 is definitely correct. My answer is going to be either A, B, or C. Now let's look at the oxidation state of manganese. I'll first look at MnO4 minus, then I'll look at MnO2 over here. So for MnO4, let's see. So the total final charge on my molecule is -1. So that's how I write my equation. The final charge over here is -1. Now let me write the charge on the respective atoms. The charge on oxygen is almost always -2. Since there's 4 oxygen atoms, so it's going to be -2 into 4 plus X, which is the charge on manganese. And now I'm trying to find X. So I will solve this equation, and then my X turns out to be +7. We have this ion, now this becomes manganese dioxide. Now let me look at the charges on manganese dioxide. It's MnO2 over here, and the final charge is 0. So I'm just going to write 0 over here. And the charge on, let's calculate the charge on oxygen. That's going to be -2 into 2 because there's 2 atoms of oxygen. So solving this equation, I get +4. So previously it was +7, now it has become +4, which means that the positive number is reducing. So manganese is actually reduced from +7 to oxidation state 4. So 1 and 2 are, 1 is correct and 2 is also correct. Now let me look at sulfur. So sulfur first exists in SO3 2 minus, then it becomes SO4 2 minus. Now I'll calculate the oxidation states for both. So SO3 2 minus, the final charge is -2. Let's calculate the charge on oxygen. That's going to be -6, which comes from, there's 3 atoms of oxygen, and then you multiply -2 by 3, you get -6. So this way, when we solve the equation, X turns out to be +4. Now let's find the oxidation state of sulfur. So this X over here is the oxidation state of sulfur. Now similarly, the final charge is -2 and oxygen atoms contribute -8. When we solve this equation, I get +6. So the oxidation state, it's actually increased from +4 to +6. So this sulfur has been oxidized, whereas magnesium has been reduced. So from +4 to +6, this is also correct. My answer is then going to be A.